Let us discuss RS nomenclature in the compounds having more than one chiral carbon. So let us number first 1, 2, 3, 4. Now we use RS nomenclature for each chiral carbon. First take second one. Now on second carbon there is C double bond OH, OH, H, and this is C, H, OH, COOH. This is second carbon. Now you know oxygen gets number 1 because it has highest atomic number at the first point and it has lowest 4. Now 2 and 3. This carbon, it is equivalent to 3 oxygen is attached to carbon, but in this case there is 1 oxygen, 1 carbon, 1 hydrogen. Obviously this will get number 2 and this will get number 3. So now 1, 2, 3. So we go like this. This is anti-clockwise, horizontal. As per rule, anti-clockwise horizontal is R. So it is 2R. Now come to third. At third, at C3, above it is C, H, OH, COH, OH, H, C double bond O, OH. Again numbering 1, 2, 3 and 4. So we go like this. Again anti-clockwise, horizontal, anti-clockwise, horizontal. So R means this molecule has configuration 2R, 3R. One more thing, it predicts that it is an enantiomer. If a molecule has 2 chiral carbons and both have same configuration, either R or S, that means they are enantiomers. That means that compound is an enantiomer. Now let us discuss its mirror image. Now if we draw its mirror image, this is the mirror image. Now without predicting its nomenclature R or S, I know that as it is 2R, 3R, so it should be 2S and 3S. Both have same nomenclature, 2S, 3S. That's why it is enantiomer of this molecule. These two are enantiomers. Now we can have an idea. Now let us predict. This is the case for C2. Now it is 1, 2, 3, 4. Go from 1 to 3. Clockwise, horizontal. Clockwise horizontal means S. So it is 2S. For C3, H, OH, COOH, COHH and COH. Okay, this is the case for C3. 1, 2, 3 and 4. Again clockwise, horizontal, clockwise, horizontal, S. So 3S. So in this case, it is 2S, 3S. This one 2R, 3R. So both are enantiomers. So this is also the way to predict whether two compounds are enantiomers of each other or not, and they are non-superimposable mirror images. Now, what about then meso compound? This one is meso compound, has plane of symmetry, optically inactive, both are identical. Now let us discuss. On the second carbon, COH, H, OH, this whole 1, 2, 3 and 4. We go anti-clockwise with lowest priority number, horizontal, so it is R. So at position 2 it is R. At third position, H, OH, COH, CHOH, COH. It is 1, 2, 3 and 4. So 1, 2, 3. It goes clockwise, horizontal. At C3 it is clockwise, horizontal. So S, so 3S, 2R, 3S. 2R, 3S, so it should be 2S, 3R. And if we have RS or SR, they are identical. So remember this thing, if both are R, both chiral carbons are R or S, they are enantiomers. If one is R, other is S, then that is a meso compound. Now, second part, this one at C2, it is COH, OH, H, OH, H, COH. Again number 1, number 2, number 3 and 4. So 1, 2, 3, clockwise, horizontal. What it means? Clockwise, horizontal. S. So it is 2S. 2R, 2S. At third, 1, 2, 3, 4. Anti-clockwise, horizontal. Anti-clockwise, horizontal. 3R. So it is 2S, 3R. 2R, 3S, 2S, 3R. Both are identical and they are meso compound. This is same compound. So in this way you can predict this is meso, this is enantiomer.